Hello Mathletes, welcome to the Math Route by Sriranjani. Today's topic is all about the magic of squares, where geometry meets arithmetic. Numbers take shape and patterns come alive. Watch the full video to know more about square numbers and their properties. First, let's see what a square number is. So, a square number is just simply a number multiplied by itself. So, we could say product of a number multiplied by itself. 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5. So, all the products are called square numbers. So, when we arrange 1 squared, 2 squared, 3 squared, that is 3 cross 3, 4 cross 4 and 5 cross 5 as dot patterns, we'll get 5 rows and 5 columns formed, and hence we call it a square number. This pattern continues to expand, thus forming bigger squares with equal number of rows and columns. We have seen how to find a square number by multiplying itself. The next representation is through exponential notation, that is the power of 2. So we write a number as the power of 2, denoting that it would be multiplied by itself twice. So instead of writing 1 into 1, 2 into 2, 3 into 3 every time, we make it as a shorter notation 1 power 2, 2 power 2, 3 power 2, etc. up to n power 2 in a generalized term, such that which means that number is multiplied by itself, finding the square number. Also, this tiny superscript 2 means squared every time. So 1 squared, 2 squared is how you read the notation. And it also means the area and growth expressed in one powerful symbol 2. The table of square numbers from 1 to 10 is given. 1 squared till 10 squared, that is 1 to 100, has been provided for your reference. Next, we move into the properties of square numbers, the hidden ending. So instead of looking into individual numbers and finding out whether it's a square number or not, we have a smarter way of finding it. So the units digit decides whether the given number is a square number or not. So if a number is going to end in 0, 1, 4, 5, 6 and 9, then the number is said to be a square number. If the number ends in 2, 3, 7 or 8, it can never be a perfect square number. So this is the smartest way of finding whether the given number is a square or not. So instead of calculating it further, we can just find it out in the first go with this smartest way. Property number 2 is the odd number secret. So multiplying alone is not the only method to find out the square number. We have the second method where you add consecutive odd numbers to form the square number. We know the set of odd numbers 1, 3, 5, 7, 9, 11, etc. So starting with 1, when you add the first number will be 1. 1 plus 3 gives you 4. 1 plus 3 plus 5 gives you 9. And 1 plus 3 plus 5 plus 7 gives you 16. Each new odd number adds a layer to the square, like building a bigger square ring by ring. The sum of first n odd numbers is equal to n square, and this is one of the most elegant property in mathematics. The next property is squaring negatives. So multiplying a negative by a negative always gives positive result, as in integers minus into minus is always plus. So 5, if you take 5 into 5 gives you 25. Similarly, if we take minus 5 squared is equal to 25. In simple words, minus 5 into minus 5 gives you plus 25. The negatives cancel out each other. So the product of negatives is always a positive square number. The key rule applied here is that the square of any non-zero number, positive or negative, is always positive. We have seen 3 properties of square numbers. Next, let us see the numbers between two square numbers. That is the gap between squares. So how many numbers are hiding between the square numbers? Let n square and n plus 1 the whole square be two square numbers. For instance, let us take 4 square and 5 square, that is 16 and 25. Let us see how many non-square numbers are there in between these two square numbers. If we count, we get to see there are 8 numbers. Similarly, between 25 and 36, there are 10 numbers in between. Therefore, between any two consecutive squares, n square and n plus 1 the whole square, we say there are exactly 2n non-square integers. So, applying the value of n, we can just multiply 2n and find out the number of non-square integers, which is one of the most important objectives of this section. The next property is all about zeros and symmetry. So we have all seen how to find out whether the given number is a square number or not from the first property. What if the number is going to end in 0? The number of trailing zeros determine whether the given number is a square number or not. So if there is going to be 1 0, it is not a square number. 2 zeros, it will be a square number. 3 zeros, it is not a square number. So in that way, if a given number is going to have even number of trailing zeros, then the given number is a square number. If not, it is not a square number. Also know that if a number has n trailing zeros, its square has 2n trailing zeros. The count always doubles. The next comes the square roots, the inverse journey, which is undoing the square. We have seen that we find the square number through product of itself, whereas the square root reverses squaring. We find one length when you know the area. So that is one good example of this application of square and square root. Find the square root of a number through various methods. One such method would be prime factorization. So finally we see the shape of these square numbers. It is more than arithmetic and they are the building blocks of area, growth and geometry. Every square number forms a perfect geometric shape when it comes to visual patterns. And the consecutive odd numbers always sum to a square, which is the odd number magic. And also one more thing is we subtract the consecutive odd numbers from the given number to find out the square root of the given square number, which will be discussed in the upcoming videos. And what's next? Explore cubes and higher dimensions. The patterns grow even wilder. How do these patterns change when you move to cubes or higher powers? The adventure never ends. Thank you for watching. Hope this video provided better conceptual clarity and deeper understanding. Stay tuned for more updates. Signing off, Sri Ranjani. Thank you.